Hello, today we are looking at very powerful setup, a digital screen sub-pixel display effect. The goal of this network is to take image and reconstruct it using geometry. Instead of flat plane, we will build the image out of individual sub-pixels, red, green and blue geometric strips, mimic how LED or LCD screens work physically. Before we build our RGB units in Houdini, it helps to understand how a real LED screen works. Every pixel on the LED screen, it's not just one light, it's actually made of 3 tiny LEDs, red, green and blue, and these are called sub-pixels. So this pixel never shows yellow, purple or cyan LED directly. Instead, it mixes light from red, green and blue sub-pixel using additive color. So if only red LED is on, we will see the red color, but if red and green are one, we will see the yellow color. But if all 3 red, green and blue channel will be on, we will see a white color. In our Houdini setup, we're recreating this idea. So let's move to Houdini. There is final result of our tutorial. So we can see here we have for each pixel we have different values for RGB. Here it's our project. It's commented at each step with sticky notes, and to create this helped me Houdini AI Assistant. So let's try to ask about network. I will select the nodes. I'll click to analyze selection. Here I'll select explanatory. It will give me more details. So ask plane selection and just hit the button. And this is the result. Let's look. So here we have the grid. We'll move to attribute from map, role project, the image, texture onto grid. Next attribute promote. Also here we have the explanation. Add node. Why the add node? It's here we don't actually want to square polygons of the grid anymore. We just want their center points and their color CD. For example, let's select these nodes. So let's ask transform this node to vex code. Start with attribute promote 1. So I add specific node name to start from here to create vex code. Let's start. So let's copy code. Let's add attribute wrangle. So here we have at the add node we have the points and color on them. Okay, let's paste the code, and we need to use attribute wrangle connect to your attribute from map 1. Okay, I'll connect to attribute from map 1, and is the same result. We will check this. Here we have the points with color. Same here, we have the points with color. So practically I can delete this part, and I'll connect here. Now I will go to LED, and here I have my LED. So here also we have the HDI from prompt and the debug selection, export documentation and export scene. So you can learn more about AI Assistant in the link in the description, and also you can find in the description this project. And next we'll start creating the LED display, and we will start by creating a dense file of points that hold the color information from our source image. So let's add the grid node. Let's change the size. Here let's set 16 by 9.3. Now we'll add the more lines. So in our case, the rows and columns determine the sharpness of our final effect. So let's set here 330 and here 500. So we'll create a very dense grid. So on this grid we'll project our image. Next we'll need to add the attribute from map. Okay, we added the attribute from map node. Now let's select an image. I will select this. Okay, and now if we look at our grid, now the color is on the points, and we will next step will promote attribute color from points to primitive. Let's add the attribute promote, and here let's select color, original class point, and the new class will be primitive. Okay, so now we have each pixel individual for each primitives. Next we will split each polygon. I will add the node split points. We split each point because we will need to assemble them. So if we will assemble without this node, we'll have just one point for this piece. So we split in the multiple piece for each pixel. Now we have the multiple points, and if we select, we can see the geometry is disconnected. Next we'll add the assemble node and we'll pack. So we see now we have just one single point in the middle of each fragment, and we'll need to transfer attribute color. Now we will promote again the color attribute from primitive to point, and we will delete the geometry. We need just only points, so let's delete the geometry. We'll add the node add, and now we see that we have only points and with attribute color. If you zoom, we see that different colors on the points we have, and here we have the image. Next step, we need to create the RGB subpixels. For each point we'll create a 3D shape that will replace every single pixel. Add another grid node. For size, let's set 1, and here 3 rows and columns 2 by 2. Let's copy that. So this will be red, this will be green, and this blue. Now we will group each these subpixels. Let's add the group node, and let's rename to red, green, and blue. Now let's merge this. Now let's add the align and distribute, and we will align our pixels. So here we need to set spacing 0.1. Okay, grid linear. Okay, let's add the transform node, and we'll change the uniform scale to 0.008. So it's small, it's very small. Let's add the copy to points, and we'll copy the pixels on our points. Now each pixel copied the color information, and if you look at our image, we see the image, and here the information, the color information. Now we need to convert that color information for each channel RGB. Let's deactivate the grid. Okay, we'll move next. So now we need to split that in RGB. So here we created these groups especially to split them by channel. Let's split the R, and here let's set the green. Now here we have the red channel. Let's add a null node and we'll rename just to R. Let's add here another node, G and B. Next, let's create the logic behind the LED screen physics. So now we on the red channel. Let's move to the green. Is the same image on the each channels. So blue, green and red is the same. Let's add the attribute VOP. And we need to convert the RGB channel to a red color, which intensity it's driven by the color from these polygons. Let's connect here. Here we have the color and we need to split that in RGB. So we will add the vector to float. And now if we connect the float value 1, we see here the intensity of the our colors. If we'll leave that, we'll have just a black and white image. So we'll create back from float values. We'll create again the vector value. So let's add the float to vector. Let's connect to color. And if we will connect the first value, which is red, we see here the intensity of the red color. It's driven by our color. Here will be more red, and on this pixel less red color, on this pixel more red color. So if we connect here, we can see here more red, here less red color. Let's copy that and we'll paste here to the green color, and we'll connect the flat value to value. Now we have the same but with green. Let's copy and we'll make the same with blue value. Now we need to merge this, and we will see that our image will be full color. Let's add the merge node. Okay, now it's full red, full color. But if you close to our pixels, we see that here we have the different intensity of the RGB colors.